three different paths will take it. So there's a semicircle. Yeah. Okay, we you are seeing three different paths. There's a quarter circle. There's a path 1. I'm indicating by arrows. There's a path 2. This is this one. There's this quarter circle. Okay, there's the initial point A, B. At t equals 0, it started. At time t, it will arrive there. So path 1, path 2, path 3. Okay, already we have discussed the distance covered. No, three different paths are there. So first of all, we'll come for the distance covered. Once again, I'll repeat it so it'll be easier. So what is the distance covered for the path? Distance covered for path 1. S1 should be equal to radius of this, let it be r. O, I'll write it. So it should be equal to r plus r by t. So 2r by t. Already we have discussed, once again, I'm repeating. And now similarly, displacement. Path 1. Let me define this as origin. Let me define this as origin. So what is the displacement vector will be? How you define displacement vector? AB bar, AOR bar plus OB bar by T. So this will be RI cap plus RJ cap by T. See, here is what the use of vectors will come. Displacement, no, only displacement, sorry. Fine. Now similarly, we'll go for the average speed and average velocity. So what is the average speed? Distance covered. I made corrections. Average speed for path 1. That should be equal to R plus S1 average speed symbol. V average should be equal to S1 by T. So 2R by T. Similarly, average velocity for path 1. Should be equal to AB bar by T. That's all. What is AB bar? Let me define AB bar. Agree, this it's a very, very important thing, which I'm going to conclude. Really very, the statement what I was putting everything, I'm just going to conclude using this example. Distance curve for path 1, displacement, average speed for path 1, average velocity. Similarly, we'll define for path 2. All the theoretical ideas I discussed now at a stretch, I'm going to cover it here now. Similarly, we'll go for path 2. What is the distance curve for path 2? What do you mean by path 2? This is a path 2. Getting this? So what is the distance covered? You are going to move along this path. It should be equal to root 2r. What about displacement for path 2? It'll be same. S2 bar. Displacement is a unique value, no? The way I put some sentences. No, similar average speed for path 2. It should be equal to S2, this one. So this will become root 2r. What about the average velocity for path 2? It will be same. Similar the last one. Able to understand? So just like the whole today, what all we discussed now, everything I'm concluding in just by this example for path 3. What is the path length of this will be pi r by 2. The displacement will be same. Path 3. Look at the path 3, that quarter circle, green color one. I'm asking you to look at here. So what is the length? How much of length I'll cover? Pi r by 2, no? Quarter circle. So what is the average speed? Average speed will be, yes, 3. I just want you to see this particular thing. Look at average velocity for all the 3 paths. It's same, no? See, this is what a student has to really learn here. They are not theoretical ideas. The ideas are not just mere theoretical ideas, the sentences. They do reflect a lot of concepts here. Always the physics, when you take examples, it'll be very easy. With examples only, it'll be very easy. So in books, you have everything statement. I just gave one example. Fine. So let me summarize here. So look at for path 1, what is the distance covered? R plus R, 2R. Then displacement, Ri cap plus Rj cap. Average speed, time, what is the time of traverse for all the path is same. That's what we assumed it. What is the assumption? Let time of traverse for all paths this is very important. Based on this is what I'm just discussing this example. If the time of traverse for all the paths are same, then definitely what happened, the distance covered and the average speed will be different, where the displacement vector must be same. Average velocity will be equal. Try to notice this. I just wanted to highlight here. Let me just highlight everything. So this is one. This is for path 1. Anybody can take examples like this and you can study it. You're supposed to, you should always take example of physics. Physics is not about reading content. You should take example, then you have to analyze. So what all I just put statements. I'm justifying all those statements today, what all I wrote just by with this example. Fine. So you please do think on these examples. Really, they're going to help you a lot. Okay, I agree this. So in today's class, what all we studied about the rest motion. So what do you mean by rest? If the body doesn't change its state of position with the time, is said to be rest. If a body changes its position, its position with the time, it is said to be in motion. Then afterwards, distance covered. Then we discussed displacement, then average speed, then average velocity. Then we took several examples where we are able to work out the distance covered and displacement. Okay, now in tomorrow's class, okay, next class, we are going to discuss about the instantaneous speed or instantaneous velocity. Okay, thank you. Let me